I know you guys don't want a product pitch. If you want a product pitch, as I said, stop by our booth during the breakout. I want to talk to you a little bit about NAND flash technologies. I say deep dive. I really got kind of 3 core areas that I'm going to cover in the presentation. There's a lot going on in regards to the storage industry today. I think all of you have expressed, or at least felt the pain that many express in regards to storage with virtual infrastructures. It's been a challenge for a significant number of years. This is why when you head to trade shows like a VMworld event, you see that roughly 40% of all the vendors are storage vendors. There's lots of ways that we as an industry are trying to solve your issues, and I want to talk to you about how flash is changing this market for you and what I mean by change is the technology behind changing the means to allow you to virtualize the entire footprint in your infrastructure and take on new challenges as you go forward, maybe containers, automation, self-service portal, etc. One of the things that I want to share with you is, in some ways you could consider this session a little bit like a myth buster session. And what I mean by that is flash is really changing what we quote unquote know about storage. I've captured a couple slides here that come from VMworld 2014 that were presented by 2 members of VMware's professional services / engineering team as they were working on a performance case. And I've tried to highlight here two items. One is that virtualizing an app actually has, and this is per VMware, has roughly a 40% performance overhead. Now, normally that number is kind of shocking to most of us because we kind of believe like, no, it's like 1-2%. Why? How can it be 40? The reality is that the latency within the disk I/O subsystem is mirrored within the hypervisor stack and thus within the application's performance. And so I want to delve into this a little bit about how I/O actually can help you advance your virtual infrastructure goals in areas that maybe you don't think of when you think of flash. Most of us think of flash from a perspective of performance. And I hear this line repeated over and over, but we're seeing a change within the industry, but it's still a small change in terms of mindset. But most folks think, I don't need all flash because, I only need it for my database or some mission critical application, maybe a big VDI deployment, but I really, I don't need it. I don't need the IOPS. And that's probably a question that we're going to tackle here in a moment because it's probably the most unfound and unrealistic statement someone can make. The second item is someone will say, okay, I get that the flash is faster and has other benefits, but I probably can't afford it. Flash costs 5-6x that of disk. I can't afford it. So we're going to talk about that as well. And then the last piece I want to share with you is when you've decided that option 1 and option 2 or concern 1 and concern 2 have been addressed, then I want to just give you some tips around performance guidance in terms of benchmarking the systems and understanding what you're purchasing. Because there's a trend in the industry, and the trend in the industry in the flash space is there are systems designed for flash and there are systems retrofitted for flash. And I think you can discover unique differences between the two. So let's jump in on the performance side and talk a little bit about the whole, I don't need your IOPS. In the storage industry, performance, such as IOPS, gigabytes a second, speeds and feeds, capacity, these are the easiest ways that vendors can market their products. The reality is it rarely has anything to do with the actual capability of the platform to service your application or your environment's needs. It's lazy marketing, but it catches all of your attention. If you guys wouldn't respond to it, we wouldn't market it this way. 1 million IOPS, 1.5 million IOPS, 0.8 milliseconds of latency, 0.6 milliseconds of latency, 0.4. And you guys, as an industry, bite into it. The reality in flash storage is latency. The reduction of latency is the unexpected and really underappreciated or recognized benefit of all flash storage. Consistent sub-millisecond latency. And I tried to create some slides. I did these last night after the VMUG dinner. So you guys are my guinea pigs as I try to express this understanding. So I made a chart here, and it's pretty basic. And it's basically showing you how CPUs are affected by disk latency, or I/O latency. Let's not just say disk, I/O latency. And as you can see in this chart, the beginning of the left side of the chart, there's an I/O request from the CPU. And that I/O request has to traverse the disk subsystem and get addressed, the data is found, and it comes back up the system. And then the I/O can be processed. Now, as we buy new CPUs, maybe we can shorten the outer edges of this timetable. Maybe we go from 100 microseconds to 90 or to 80. But that's incremental gains and really minuscule gains relative to the latency of the I/O stack today. In this example, I'm using a moderately performant latency of 5 milliseconds. And what I've tried to do is try to calculate the CPU utilization based on wait time and try to come up a ratio here, which is basically saying that with a 5 millisecond latency, you're getting about 3.8% optimization on processing that I/O. The remainder of the time, that CPU process is in I/O wait. If I move the disk system from 5 milliseconds to what I'll put up as a common sub-millisecond range, it's 600 microseconds, and if you're an all-flash customer and you're like, well, I get 400 or I get 800, look, trust me, the results in this don't matter as much because the order of magnitude in terms of the gain. But when I can pivot from 5 milliseconds to 600 microseconds, again, a common capability, my CPU utilization goes from 3.8% up to 25%. And how this manifests in your environment is you can correlate what your average disk latency is to CPU utilization benefit. In the example that I shared with you, moving from 5 milliseconds, which again is a fairly performant disk system, average latency, mind you, to sub-millisecond consistently, it's a 6.6x gain in the performance capability of your server. And if your latency is higher, and that's why I try to build this chart going to 10 milliseconds, 15, 20, and 30, you can see that ratio really balloons. Now, for some of you may say, hey, some of those numbers are unrealistic. I don't see 20 milliseconds latency, or I don't see 30. Well, I have 30 up there because, right, in the vSphere 5 time frame or platform, 30 milliseconds is the minimum threshold before SIOC can kick in and you can have storage DRS move a workload because the infrastructure has deemed it to be too unresponsive. So whether you're hitting 30 milliseconds or not, I think it's a ratio that's relevant within the technology that we all use. So the bottom line on this is by simply taking out the slowest data transport in your infrastructure, which is the disk subsystem that we all have today, the mechanical disk subsystem. And I don't care if it's all disk, hybrid disk, disk with a cache tier, local disk, shared disk. Take disk out of the equation, you get to experience gains like this. And then these gains then manifest themselves in a couple of ways. And the first one is on the conclusion line here. You'll either be able to, A, run your applications faster, which is what everybody says, yes, that's why we bought or want to look at acquiring Flash. The obvious reason, right? Accelerate the business. That may mean you can now virtualize that database or SAP or Oracle that maybe you couldn't in the past. But more importantly, and what more people are starting to recognize after they've deployed Flash, is you can probably cut your server footprint by a third or a half. And that means you can then cut all your associated software licensings with that footprint by a third or a half. So we've had infrastructures, customers, and this is just one example. It's not a public use case, but it's a very large wireless provider in the United States that brought in all Flash for their Oracle instances, and they cut their licensing by $6 million annually on simply purchasing a $1 million array. Now, I realize $1 million array may not be what you're looking for, but that is a very large configuration. But that's a 6-to-1 immediate return on investment. I think more importantly, if you're saying, look, I'm going to make a purchase for storage and it's in the $50,000 range, and I'm using dollars meaning US dollars, you can still see these savings and impact back through the rest of your virtual infrastructure. If, by contrast, you're not looking to reduce servers, but you're looking at a use case like VDI, the converse of this is if you deploy all Flash, you can probably double the number of desktops that you run per host in the VDI space. Again, this becomes around density, efficiencies in your data center. Now I want to pivot back to IOPS because I'm not trying to undersell the fact that flash systems are performant. Unfortunately, I can't share with you what the average customer I/O level is within our install base. We've shared online, our average data reduction. We've shared online average block size. We haven't shared average data reduction for most customers. And part of this, again, goes into the element that, from a marketing perspective, storage vendors like to show you the upper end of their performance limit. But the reality is most customers don't run consistently at that upper limit. Most customers run at a very moderate level. And then changes in the workload occur through the day that spike the I/O limit. And when that spike occurs is when you feel the pain with your current disk-based storage infrastructures. Those spikes are when your caches get exceeded and performance tanks. It could be an end of quarter or end of day batch operation. It could be some type of database report. It could be backup, whatever the backup process is. Whatever changes the steady state to be a burst state tends to blow up storage performance. And this is where you see the second benefit of all flash arrays for the non-performance seeking customer is because there's 10x the number of IOPS, the platform is natively more capable to respond to a change in workload without you having to take any action or the infrastructure take any action. So this is an example of a customer, and you may have seen this in other formats before in the past, but you can see here how the customer's latency spikes based on changes in the workload, and when they move to all flash, it just levels out. So again, I'm not talking about trying to achieve 1 million IOPS per second or any crazy number like this. I'm trying to say the reality with flash or all flash storage is that and this is any vendors. I want to be clear here, right? Obviously, I work for Pure Storage. Again, you can go talk to us at our booth about what we do. The reality is any all flash storage is better than what you have with any form of disk-based storage today. And I would encourage you to look at this because you can get to a point where you will stop doing all the storage management that you're doing today. There's been a trend in the industry, and some of it was stated by the earlier presenter about we've got to embrace change, right? We're VMware admins. We are, in many cases, the change champions or instigators within our infrastructures. And we did the whole virtualization. We've done automation. Maybe we're going to do containers next. We don't know. Along that line, there was always this talk in the VMware space that the server, network, and storage teams would all eventually merge into one. And for some companies and organizations, that's true. For most, it's not. What I will share with you is that for our customers, we're seeing a lot more of the server and storage teams start to merge into one by simplifying the storage footprint. The networking teams still kind of remain separate because that's a unique and different skill set. But that convergence is happening. So I want to share with you here, this is just a chart, and it comes from a recent ESG report. And this is just to validate some of what I've shared with you. This performance bar starts on the left-hand side by running a 15 seat VDI environment. And you can see it's running at around half a millisecond of latency. And through this test, they've added additional workloads. So now they start an Exchange server for the same 1,500 mailboxes. They start a data warehouse, an OLTP workload on SQL, followed by a subsequent OLT workload on Oracle. And based on latency, which is really the quality metric in terms of how responsive are your applications, it's the quality metric that your end users are going to report to you on or pick up the phone to call you. You can see that basically the response time doesn't change as this load continues to increase on the system. And this is the benefit where we start to talk about IOPS, because now you've got this inherent capability within the IOPS set to absorb more workloads. A different view of this, and this is from the same report that if you're interested, I'd ask you to look at, is showing you failure states as they occur with this same working set and how performance stays very linear and flat. And not that there aren't any dips. Some of the failures are a little more impactful than others. Probably the largest one here is in the center here, where there was a reboot of one of the controllers in the array, and you see a performance dip that lasts about a minute. Those time intervals, for those who can't read in the back, are every 5 minutes. And so again, a very different type of impact within your infrastructure. Now, I didn't get time to create a slide, and what I wanted to share with you is as we said within vSphere 5.5 and the 5.5 platform, SIOC and storage DRS, institute migration services to balance workloads when the storage performance gets too high, when it hits 30 millisecond threshold. That threshold was reduced in vSphere 6 to 5 milliseconds. The reality is when you purchase an all-flash array, is you get a support ticket opened when you go above 1 millisecond. So what I'm sharing with you is customers who adopt all-flash arrays have this really different experience, which is storage DRS events stop occurring. And you can say, okay, well, I don't really care about storage DRS events because that's a means to ensure performance, and flash ensures performance. But there's a downstream effect to when you negate storage DRS events, which is if you're using array-based replication for DR or archive, the amount of data that goes over the wire daily all of a sudden greatly reduces because you're not shuffling the virtual machines onto different data stores, and usually your replication policies are based on data stores. So you minimize the change rate on your data stores exponentially in many cases, moving from customers from hundreds of gigabytes replicated or terabytes today down to tens of gigabytes. It's really interesting, this downstream effect of moving to all-flash storage. Okay, I want to pivot here. How are we doing on my time? I think I took off my phone. So if I'm going too fast, then I got more details than I have slides. Okay, 10:30. We go to what, 10:45? Okay, perfect then. So data reduction technologies are really the norm with all flash arrays. And this is a really brief primer. And some of you are going to say, look, I know about dedupe and compression. Trust me, I've got something good for you. Hold on with me for about 3 or 4 slides. So just to level set with everybody, right? So what is dedupe? It means in your storage array, you only store unique blocks of data. What is compression? Compression says then that data that you've stored on the array that's unique is stored in a dense or more capacity efficient manner. That's my simple manner. Some say these two technologies are interchangeable, and they're not. They're complementary to one another. So deduplication is really good with say, virtual machines, the binary sets, the applications. If you're doing file services, you could see some benefits in there. Conversely, compression is really good with structured applications, right? SQL, Oracle. Also provide some benefits to file services and as well as to the virtual machine binaries, but different use cases. And if you have an array that has one or the other technologies, you'll see vastly different results, okay? Now, your key is, if you're looking at deduplication, is the granularity of the deduplication correlates to the results that you will see. The finer grain the level of data reduction, the greater the storage savings. Now, I'm going to apologize here because I'm going to provide for you a marketing-ish statement. But basically, what we see when we're between 512 byte data reduction capabilities and 8K data reduction capabilities, and we observe this in proof of concepts, in customer installations, etc., is we observe about a 2+X data reduction result. The delta between 512 byte and 16 kilobyte is in excess of observed 3 to 4X data reduction results. Now, data reduction results reduce your price to acquire this technology. It's the key that makes it available for you to look at versus disk storage today. It also allows you to greatly extend your current data purchase cycles. If your data growth rate is going along with your current array and you're purchasing storage, say, on a 6-month interval or a 12-month interval, if I can give you 2-to-1 data reduction, it means you're going to move that 6 and 12 months to 12 and 24 months. Right? So it has a downstream effect in terms of your cost. Not to mention reducing the rate at which you're filling up rack space in your data center. In addition to data, I kind of skipped ahead with the dedupe. In addition to dedupe, compression is an interesting animal as well, which is most inline compression, and this is going to includes arrays as well as applications, is very lightweight and gives you very moderate results. I put 2-to-1 up here, but we probably would say the industry norm is somewhere from 30% to 50% savings, so maybe 1.5 to 2 to 1 as a ratio. The reason for this is you can receive significantly greater data reduction results with more aggressive forms of compression, but those algorithms consume more CPU cycles and require more I/O processing time. So anything that's inline is always lightweight because the goal is to preserve the front-end performance and to give you some form of data reduction capabilities. Some platforms, and there are more than one in the industry, have additional, more aggressive background compression processes. Those processes tend to drive up a significant greater data reduction capability because they're done in the background as an optimization after the inline. Now, I want to pivot. Thin provisioning is an interesting technology, and I like to think of thin provisioning as more of a suite of technologies, but it's interesting from a perspective of how the storage industry looks at it. Some vendors are like, thin provisioning is absolutely data reduction technology. It reduces the amount of capacity that's lost when you provision storage by saying it's now provisioned on demand. That's debatable depending on vendors. I like to look at thin provisioning as a suite of technologies that does allow you to have dynamic provisioning capabilities and does allow you to not waste capacity for provisioning storage and hoping that it someday gets used. But it has a number of sub-technologies that help it actually deliver on that promise. Technologies like zero removal and pattern removal, which are technologies that volume managers and file systems put in place to try to override thin provisioning. If you're not familiar with like a zero removal technology, right? Think of an eager zero thick virtual disk, right? It's fully formatted so that you can have optimized performance in the disk world, so you don't have to seek to, as you grow your thin provision virtual disk or your applications need for capacity grows. Pattern removal, patterns like ASM and Oracle writes patterns to try to override the volume manager on a thin provision LUN. So arrays that can eliminate zeros and pick up the patterns, force that override to remain thin. And then technologies like T10 unmap, which is a SCSI command, allows those thin constructs to remain thin through the life cycle of your data footprint. Most of you who are running VMware, whether on NFS, VMFS, Fiber Channel iSCSI, Fiber Channel over Ethernet, are probably wasting somewhere between 20 and 50% of your storage capacity today with data that's been deleted but yet resides in the virtual machines. Thin provisioning and T10 unmap allow you a way to reclaim that. Okay? So I want to give you a basic example of thin provisioning really quick, and then I want to jump into unmap. So this cylinder is meant to represent a LUN, and a LUN has been thin provisioned and it's half full, so it gives you 2 to 1 data reduction. The challenge in the storage industry in terms of marketing when you're looking to purchase flash is that thin provisioning is a dynamic form of allocation. And so I can literally go on the array and say, well, increase the size of that volume or that LUN, and now my ratio, my storage efficiency ratio just increased 3 to 1, but the data was never reduced. And I can go on the array again and make it larger, and now my ratio becomes 4 to 1, and again, capacity is not reduced. So this is the slippery slope when you want to include things like thin provisioning in your data reduction technology, or your data reduction savings equations. Maybe that's a better way to put it. It's the same slippery slope as looking at snapshots. One snapshot, hey, 2 to 1, 2 snapshots, 3 to 1, take another one, 4 to 1, right? So you need to be educated around what's going to actually reduce your capacity footprint and what's a dynamic form of provisioning. We try to do so on our website. This is our old ticker that's really denoting between data reduction and data reduction, including thin provisioning, which we call total reduction. Now, I started to speak around unmap, and this is some data I just came across during this trip. Customer data. This is a screenshot grabbed from within one of our GUIs on the flash array. And this is a customer who recently upgraded to vSphere 6 and went through the steps of enabling the virtual machines and the hypervisors to process end-to-end unmap. Or another way to think about it is per VM enabled T10 unmap. And what you observe here is you can see in the center of the chart here, where the blue and the purple is you see this big precipice on November 3rd of the storage capacity. It's actually a reduction in 41.1% of their storage footprint. Now the top line, the purple bar doesn't change. You see a change between the blue line reducing and the purple line expanding. The purple line is snapshots. The customer stores 28 days of snapshots. So while their array didn't receive any reduction in capacity, it's because the accounting for those deleted data blocks that you could never free up in the past if you were on vSphere 5 or any previous version, right, is now in snapshots. And when those snapshots roll off, so will that deleted data. It'll be gone. So a couple weeks from now, this customer is going to start receiving a significant reduction on their total capacity on the array. 40% footprint reduction on your virtual infrastructure is a 41% reduction in your cost of storage. This goes above and beyond, and this is where I think thin provisioning has some consideration with technologies like deduplication and compression. Why store data that you have deleted in the virtual machine on your very expensive storage or all-flash array? Now, there's a couple requirements for this, and I want to cover them just briefly. Right, you got to be on vSphere 6. You've got to enable block delete on your on the host itself. You've got to upgrade the virtual machine hardware to version 11, which is probably the most difficult component in this. There's a setting that you can automate when the hardware gets updated. So when the virtual machines reboot, the hypervisor will step in and will go ahead and update the hardware. So that's a good setting that you'll put in place today, and somewhere along the line through a patch or a service pack or whatever it may be, whether it's a day from now or a year from now, those virtual machines will start to update. There's also a requirement here that I didn't put on here, which is the virtual disk format has to be thin in the hypervisor. So you may also have to go through some storage vMotion migrations to enable this. It should probably be considered, and I'll write it up in a blog post, considered as if you're going to adopt anyone's all-flash product. You should probably start converting to thin provision as you're just doing the migration. Last but not least, know that VMware's implementation is based on SCSI 2 protocol, not SCSI 4. SCSI 2 is enabled in Windows 8 and greater guests. SCSI 4 is in Linux. So if you're primarily a Linux shop, you're going to need to wait until you can really leverage this capability. If you've got a fair amount of Windows, modern Windows operating systems, you should start to see these savings. What did I have in there? Oh, so here's a good capacity. So I built a chart here. The orange bar is showing pure with vSphere 6. The blue bar is pure with vSphere 5. This customer, this is the same data, I looked at it a different way. This customer is on average running around 5.5 to 1 data reduction across these 5 data stores. You can see the bar drop on all of these, right, being the capacity. What I wanted to do was model this back out where I took his requirement, because all these virtual disks are thin, and say what would it look like on a regular traditional storage array with thin provisioning, and then even furthermore, what does it look like if I do something like hyper-converged and I'm using commodity storage? Because again, we go through this price concern, which is, hey, what's the cost of storage? This bar on the left is now represented here in the same colors on the right, but you can see by data reduction technologies as well as thin that you're talking about an exponential growth in terms of raw storage capacity. And this is my other point, which is I think modern storage platforms should force you to start looking at effective capacity in your price modeling versus raw capacity. If you can store tenfold the amount of data, then the price per gigabyte on that platform is 1/10 of the alternative. Okay, last issue. I'm gonna look at my time. All right, got a few minutes left. Is performance testing. I put this slide up at VMworld, other forums. This was in a joint session that Chad and I used. I love this image. If your goal is to race a Formula One race car, which I think is a good analogy for, hey, I want to kick the tires and proof of concept of some storage array, and it's all flash. How fast is it? Then what type of testing you do may or may not be relevant to running around a racetrack, right? And if for some of you, if you can't see, so the upper left corner is, desert beach. Bottom right corner is a frozen ice pond, or ice, a frozen pond. The bottom left is in the mountains. Good data. How it correlates to running on a track, I don't know. But we see this behavior with storage admins. If you're going to test an all-flash array for your VMware environment and you don't have responsibility for storage, please go hug your storage admin and help them understand what you care about, because they may have a different set of criteria. So here's my high-level guidance, please. When testing performance, please make sure that you do it under normal operations, when the system's near full, inject failures into the device, do it during software and hardware upgrades. Make sure you're doing it if you're going to use replication, benchmark it with replication running. If you're going to benchmark it with snapshots, take snapshots during the test. In other words, don't benchmark the box in a vacuum, the box meaning the storage array in a vacuum. Benchmark it how you plan to use it and how you expect failures to occur. This is what many don't do. And this will really, I think, share with you differences between some of the platforms in the storage space today, where some are designed to say, well, performance trade-offs are what you pay for, which I think is the norm in the industry, and more modern platforms that have been designed to say, you know what, in the day and age of cloud computing, you're not paying for a performance trade-off anymore. What's more valuable to you is that nothing changes in terms of performance. Next is, when you can, please try to use actual data. It's sometimes much more advantageous for you to restore from a backup a true data set and see how that platform runs with your actual data than to try to come up with some wizard of synthetic data test. First is that most synthetic benchmark tools were not designed with the construct of data reduction platforms or storage platforms. As such, when they implement things like data patterns to try to write out data sets, sometimes they're a string of zeros, sometimes they're just a repeating string of a binary string. You get really weird results like uber high data reduction ratios. You can't fill the box up. Tools that currently are kind of suspect in this space that we've seen challenges with customers include Iometer, which is a pretty common tool for most of us in the Windows space, but also SQL.io, Disk Speed, ATTO, and FIO. A recommended tool that was designed for data reducing arrays is VDBench. And what I would just caution you with that is never let one vendor dictate how you're going to test a platform. In addition, some customers want to try to fill up an all-flash array or a data-reducing array using non-reducible data because it's the fastest way to fill it up. Understand that it is the very rare instance that an all-flash array cannot reduce data. So here's the key. Today, all-flash arrays work really well with structured data sets. Structured data sets reduce very, very well unless they're encrypted. Then they don't reduce very well. So if your use case is currently the data is already encrypted above the storage layer, then go ahead and test with a non-reducible data set. Otherwise, by using a non-reducible data set, you're going to get false results. You're going to inject things like an increase in garbage collection times, which is a decrease in your performance. You're going to do things like not optimize the back-end I/O buses because compression allows you to stick more data on the wire and thus transfer more data or have greater bandwidth. So again, if you are dead set on doing a synthetic test, please try to be realistic to what your data set is. And if you're having questions because you go, I want to use non-reducing data sets because I don't know what my data is, have your vendors share with you what their install base is. Odds are your virtual machines aren't very different from everyone else's virtual machines. Okay, with that said, I'm going to get a little marketing here as we close. I've been privileged to be in the storage industry a long time and did a lot of fantastic work with VMware during my time frame at NetApp. But I saw this trend and I moved over to Pure. I'm in my third year at Pure Storage. But I saw this trend occurring in the market, which was the adoption of all flash. I think we're in a really interesting time frame here, which is you see the market mature. Last year, flash became really the new tier one. You see every vendor have an all-flash platform, EMC, NetApp, HP, right? All the old guys now have new technologies. I think we're on the cusp of flash moving from the high-performance tier into the capacity-optimized tier of storage. Innovations in density and the platforms that are going to bring these dense products to market, I think you're going to see really emerge in 2016. And we're going to start talking about capacity-optimized data sets, whether it's backup, NAS file services, CAD/CAM, archives, whatever it may be. And you can sit there and say, again, I don't think I need the performance for capacity-based storage. You need the footprint and the reduction in power cooling so that you can store more data going forward. So it's an really interesting time in market. And I'm getting the wave here. Last but not least, we've helped tons of customers adopt all flash. I know this is my sales pitch slide. My apologies. Hopefully you recognize some of these logos. If you want to talk to us, stop by our booth. Be happy to go into the details of how our box operates through the characteristics that I've shared with you here and or expanded use cases within the VMware and application space. With that, I'm Vaughn. Thanks, guys.